Hello, my name is Mile Rangilov and I'm a Python software developer in the developer relations team at VMware Carbon Black. Today I'm going to talk about remote debugging of Python applications in constrained environment. But first, couple of words about my background. Prior to coming to VMware, I have been working for years in the embedded, actually automotive industry, writing C applications for POSIX-like operating systems, and as you can imagine, I'm a pretty much Linux guy, accustomed to text user interfaces, to consoles. Yes, I'm getting old. So in the C++ world, and that is a little bit Linux-centric, the tool of choice for debugging your code is GNU Debugger, or also called GDB. GDB by itself lacks remote debugging features, so for this reason a separate tool called GDB server is used, and GDB server actually runs on the target where the program debugged is being run, and GDB in turn is used as a client. Communication might occur, normally occurs over TCP sockets, but it can also occur over a serial connection. GDB server, GDB in turn can either run the binary to debug, or it can attach to an already running process on a Linux machine. And IDEs such as Eclipse typically build upon GDB and GDB server to provide a more user-friendly experience. Like I said, I'm not kind of an IDE guy, more like a console one. But anyway, the challenging scenarios that typically occur with remote debugging are commonly related to networking limitations and firewalls. Not only networking, but mostly, and they cannot be resolved solely with the means of the debugger itself. You normally have to do something else outside the debugger itself. The IDE-based solutions are typically able to run the binary itself. I mean, you create a debug configuration and when you start debugging, your binary is being uploaded to the target where it runs, and you debug it. But it normally, in most cases, cannot attach to an already running process on the target. That is with the C binaries, but how about debugging Python code? So with Python, there exists a number of GDB-like and not GDB-like debuggers. Some of them are even integrated in IDEs, such as PyCharm. They are generally limited to running the program, but they cannot attach to an already running process. There are some workarounds to that, which I'm going to discuss later in this demo. So, like I said, there are a number of solutions for debugging Python code. Even GDB itself and the GDB server can be used. However, it is a very low-level debugger. It uses ptrace. It expects the binary to have debug symbols, which is often not the case. And yeah, you can track binary executions, it's called execution, you can inspect the register values, you can get your stack trace, but from Python perspective, it's not really very useful. The good part is there are a number of debuggers which are like made for debugging Python code, such as PDB, PUDB, which were great. Unfortunately, they lack remote debugging capabilities. PDB++ is even better than them, but it also lacks remote debugging. A good remote debugger that I have found is MadBG. It works really great. The bad thing about it is that it's not multi-platform. It relies on a certain Linux syscalls, Linux specific. So for that reason, you can only run it on Linux. Actually, even that's not correct. You cannot build it on anything other than Linux. So you cannot have like a debug server built for Linux and then a debug client running on macOS, for example. Also, there are a number of abandoned projects. Some of them are real good, but unfortunately abandoned, like WinPDB, RPDB2, PYDB. They are not maintained anymore, unfortunately. We also have IPDB, which is closely tied to IPython, and for that reason, in most cases, it is not quite useful to us. There are, of course, IDE-based solutions, such as PyCharm, and also Visual Studio Code also has remote Python debugging capabilities, from what I know. So far, my personal favorite is the Trepan family of Python debuggers. Trepan 2, which is a Python 2 debugger, and Trepan 3K, which is the Python 3 debugger. About Trepan, its syntax, first it's a console-based text user interface, very much GDB-like, which I really appreciate. And it has remote debugging, it supports remote debugging out of the box. It's actually one of its core functionalities. Trepan is multi-platform. It runs on Windows, Linux, macOS. It has all the essential debugging functionality available, such as breakpoints, object inspection. You can inspect objects, you can have backtraces, you can step, continue in the code, you can inspect the function, return values, etc. It also has the cool ability to evaluate the current line without really executing it, which is kind of neat and very useful in some occasions. You can also inspect the currently running threads. You can see which function they are into. You can get backtraces of them. And the cool thing is it has syntax highlighting for Python code and even for some of the command output. And it has also command auto-completion, which is really neat. It has some limited ability to debug Python bytecode without having the Python source itself. However, this is not quite useful, and it very much resembles debugging with GDB when you don't have debug symbols. Trepan has a few disadvantages as well, like it cannot attach to an already running process. This, however, can be accomplished by means of some minor code modifications to our code being debugged, and I'll cover on this later on. Another disadvantage of Trepan is that it, unlike GDB, is not able to trace any fork child processes. So, for example, if your Python program executes some external command, it won't be able to trace the command itself. However, Trepan is a Python debugger, and in case your executed command is not a Python program, it doesn't make a lot of sense to inspect it with debug it with a Python debugger anyway. So how do we debug? How do we do remote debugging with Trepan 3K? On the target, you have to run the Trepan debug server, obviously, and it's as easy as running this command: Trepan 3K --server --. The program you are debugging plus any program options that you might have, program arguments. On the host side, you need to run the debugger client, which is a separate program called Trepan 3KC, and you have to provide the host and optionally the port. Debugging itself, like I said, it has a text-based interface, resembles GDB quite a lot. Like GDB, it has shorthand commands like S for step, C for continue, R for run, B for setting a breakpoint, etc. You can get a backtrace with just BT. A cool thing about Trepan is that you can inspect object and object values by just typing the object name. Like I think in this screenshot we have it with num. Yeah, num equals 5 as a string. Also, Trepan has contextual help available to assist the user. You can get detailed information on your Python source code files, the global variables, the threads, the local variables in your scope, of course. You also have the eval command to evaluate the current line without executing it, a cool feature that I mentioned already. So how about the challenging and constrained environments? So, like I said, in many cases, the challenges are related to network configuration, firewall rules, like network address translation environments. And in most cases, those can be overcome in a simple way by setting the appropriate IP tables rules for setting port forwarding, for example, to punch through the nut. This is something which obviously the debugger itself cannot do, but it's quite simple nevertheless. Another challenge in some setups is sometimes you are not able to run the debugger server for some reason. Like, for example, you cannot connect via SSH to the target and run it. You might not even have an SSH server. For those cases, there is a workaround, and you can place a little snippet in your source code, which is here. It's just like 6 or 7 lines. You just need to import the necessary Trepan modules. You need to set up the connection options, like in this case the input-output is via TCP network socket. The port is 12345. You have to instantiate the debug server interface, set the debug options, and then just run the debug session. This snippet of code can be placed anywhere in your source code. You don't need to put it into your main method, so you can put it anywhere you wish. As a real-life example, earlier this year we released version 2.1 of our Carbon Black Cloud IBM Curator app. We are currently working on version 2.2. So first, what is IBM Curator? IBM Curator is a SIEM software. It is responsible for gathering security-related events from a wide range of appliances or sources. Those could be firewalls, switches, routers, like antivirus programs, and in our case, Carbon Black Cloud. So our application is responsible for ingesting alerts and audit logs from Carbon Black Cloud and feeding them to IBM Curator via the TCP syslog protocol. We also provide a number of Carbon Black Cloud related actions and make them available through the IBM Curator web interface. And those actions might be, for example, dismissing an alert, or banning a hash, or quarantining a device, etc. Our app consists of two parts. First is a Flask-based application. It is a web service which provides most of our UI functionality. Together with the Flask application, we also have a separate script which continuously runs and pulls the Carbon Black Cloud backend for new awards, for new audit logs, and once gathered, it does some data modifications and then sends them to curator via syslog. So what challenges that we had with remote debugging with our app? First, curator apps run inside their own Docker container, and those containers lifecycle is managed by the curator services, not by us. So in effect, we cannot start or stop our containers. We can, of course, stop or start the curator service responsible for this, but it's quite of overkill. Also, another issue is that the network configuration, the firewall configuration, at least by default, prohibit us from making any inbound TCP connections to anything running in those Docker containers. I mean, no server listening in the Docker container can be connected from an outside machine, from the network. And the worst of all, we have no control over our program execution, which is strange, but our application services are started and monitored by a watchdog service running inside the container. This watchdog is called Supervisor D, and Supervisor D is responsible for starting them, and in case they crash or get killed, it is responsible for restarting them. So, how did we overcome those challenges? The networking challenges were easy to fix. It's just about IP tables rules, so we just inserted a firewall rule into the Docker user chain, which allowed machines from the network to connect to make inbound connections to the Docker container on a certain port. It's quite easy. As far as the program execution and container lifecycle challenges that we had, obviously we cannot SSH to the curator machine and attach to the container, then kill the already running process and start a debugging session, because the supervisor D watchdog would instantly restart it. And having two instances of the post script running at the same time is a big recipe for disaster. Furthermore, we cannot kill the supervisor D watchdog, because in this case IBM curator will just restart the whole container, which is obviously not something we wish to happen. So rather than running the debug server in the container, we did this little source code modification, putting the magic snippet in a bit weird location in a signal handler. Why signal handler? So our application internally uses Unix signals as means of an inter-process communication mechanism between the Flask application and our polling script. It is commonly used to signal for configuration changes, such as the user changing the configuration in the web UI, which is managed by the Flask application, and when that happens, the Flask application sends a certain signal to the PostScript, and in the PostScript we have a signal handler which is responsible for reloading the configuration. So in that very same signal handler we put our debugging snippet. So what happens in effect is when the user changes, does even a minor change into the configuration through the web interface, it triggers a remote debugging session on the target. So all that is left is to run a Trepan client from your host, from your laptop, connect it to the Docker container and start debugging your application. And then you can step into your program, inspect objects, set breakpoints, and do whatever is being done in a debugger session. Unfortunately, due to some time limitations, and not only time limitations, I won't be able to do a live demo of debugging our Curator app. For that reason, I included a screenshot from a real debugging session, and you can see a Trepan in operation. First, it gets you the return values of a function, and then you can step into the code, get a backtrace. Even the backtrace has this neat syntax highlighting. You can get a list of your program, see where you are at, again with syntax highlighting, which is very nice. And yeah, for a GDB user like me, this is really great. As you can see, Trepan 3K is quite a powerful debugger. It allows you to do quite a lot of things remotely, and is rather useful, especially for some challenging cases like developing Curator apps. So thank you, thanks a lot, and if you have any question, feel free to ask me. Thanks again.